Hi guys, so we're going to be solving this question. It says to find the transfer function for this system. So first of all, let's deal with the mass M1. So we're going to focus on the forces on the mass M1 due to only M1. It means hold this thing, like don't allow it to move basically, and then push M1 in the direction it's supposed to go in. So in this case, when I push M1 to this side, what will happen? This spring K1 will be trying to drag M1 back. So K1 x1 it's supposed to be k1 x1 because the direction is moving is x1. So in this case to select this, so k1 x1 is, I'm just transferring to Laplace immediately. It's much faster to solve. The next force you will notice here is this force. This is actually a damper, and you can see it's literally going in this direction, so we're just going to add it here to be fv1 s x1 s, because x1t in Laplace will be x1s, and damper in the Laplace system is, you can see it here. So that's just it. Next, as M1 is still moving in this direction, we're going to notice that the applied force is also moving in this direction. So it will be F of S. You can see it here. And then there's also a force on the mass due to the mass, because mass opposes the linear motion. So M1 x dot dot 1. But when you convert it to this thing, it becomes this. So it's going to be, that's basically mass times acceleration. It's going to be m1 s square x1 s. Now, still the mass is moving in this direction. You notice that it's pushing this damper and this spring in. They will not be trying to push the mass backwards to the position it's supposed to be. And that's how a spring and damper work. The whole duty of it is to push the person on his back to his position of rest. So it's going to be pushing in this direction, pushing the mass to go back. So it's going to be FV3 SX1S and K2 supposed to be X1. In this case, it should be X1S. And the second thing you have to consider is the forces on M1 due to only M2. So in this case, right, hold M1 stiff and move M2 in the direction it's supposed to go, which is here. So you will notice that in this particular case, let me draw M1. The spring and damper are going to be dragging it like this. So we're going to have FV3 S X2, because the distance we're dealing with here is X2 S, and K2 X2 S. And so then when you combine everything, both of them, now you can see that this and this have a common factor and they're going in the same direction. So I can honestly just rewrite this as K1 plus K2 X1S. Just erase this. I see that this and this also have the same thing. So I can rewrite it as FV1 plus FV3 SX. And I can just erase this because they're going in the same direction, so that's why it's plus. Now this one I can just put it to this side. I just broke it down so that you understand what I'm talking about. So just going to write all this here. So now this is the total force acting on this mass. I will just write it out here. So it will be m1 s square. I'm factorizing everything that has the same x1 x1s. So m1 s square plus fv1 plus fv3 plus this k1 plus k2. You understand what I'm factorizing, Lisa? X1s. The other one that has common factor of x2s. And now for the other side, sum of applied force is equals to sum of opposing forces. So this is actually an opposing force. It's actually supposed to be on the other side. So it will be FV3 plus K2. No, sorry, I forgot the S. Plus K2 X2S plus Fs. Now you can take this to this side, so it will be negative. So I'm just going to erase it and put equals to here. I just took this to the other side. So now this is our first equation. Now let's do for M2. For the mass M2, we start by checking for the forces on M2 due to only M2, which means we'll hold this mass and move M2. So if we move M2 in this direction, what are we going to get? Let's draw it out. This is the mass M2. As it's moving in this direction, it's going to be compressing the spring, which means this spring will be trying to push it back. So we're going to have a force here, K3X2S. It's from this point that I got it. And as it's moving in this direction, it's going to be trying to pull this damper spring, but then the damper spring will be trying to return it back to its position. That's literally their job. So these forces are going to be in this direction. So FV3 S X. The distance limit is 2, so S. And then this will be K2 X2 S. And then don't forget this force as well. I keep forgetting it if I'm being honest. FV2 S X2 S. And then the mass itself opposes its motion, which is going to be in this direction. The motion is going in this direction, is trying to oppose the force. So it's going to be mass M2 X dot dot 2. You can see it here. It will become M2 S square X 2 S. The other thing we're going to consider is the forces on M2 due to only the motion of M1, which means in this case, hold this and move only this and see how it affects M2. So for that one, let's draw it out. As you try to pull M2 in this M1 in this direction, it's going to be for making this damper and spring to push on this M2. So we're going to have forces like this. It's going to be FV3SX2S and K2X1S. Sorry, in this case, is the distance moved by X1 that's affecting the system. In this case, so it's supposed to be X1. So now let's just summate the forces. This You can see that this all have the same factor of x2 and they're moving in the same direction. So we can literally just write all of them as FV3S plus K2 plus FV2S plus M2S squared plus K3, all of them with x to s. And the opposing force in this case is these two. This one's going in this direction, this one's going in this direction. So we can just write them here to be FV3 plus K2, then X1S. You can bring this to this side to become minus, and then everything will be equals to 0. So now we have our two equations. We can now get to solving. So in order to make this easier, I'm going to group them. Z1, let Z1 be equals to everything here. And we know the coefficient is this, so I don't need to write that. We'll write it at the end. And then for, I see this is actually a repeating factor, so we can just assign it to Z12, just so that you know it belongs to mass 1 and mass 2. FV3S, don't worry, the signs will not be forgotten, plus K2. And then for the last one, which is, let's call it Z2, that's for this entire equation here, FV3. Sorry, I forgot to write S here. I forgot about the S. Please do not forget to put it. It's very important. So now The equation 1 in this case will become, actually this is both equation 2 and this is equation 1. So equation 1 will become z1 x1s minus z12 x2s equals to fs. And equation 2 will become z2x2s minus z12 x1s equals to 0. Now from this second equation here, this second equation, first equation, make x1 subject to formula, because you remember what we want is x2 over fs. So I want to find the way to isolate only x2. I see that here x2 is here. So I can make x1 subject formula here and substitute into this so that all I will have is x2 and fs. That's just the essence of what I'm about to do now. So from here, if you make x1 subject formula, it equals to z2 over z12 x2s. Basically, if you take this to this side, then you divide both sides by z12, you get this answer. Now substitute into this, you're going to have z1, right? Um, z2 over z12 x2s minus z12 x2s plus fs. So we're getting exactly what we want. Now we have only x2 and fs in the equation. Now we can multiply z, it becomes z1 z2 over z12 x2s minus z12, sorry, x2s equals fs. We can just simplify this, come all over z12, z1, z2 minus z12 square equals to f of s. I basically just, since both of them had x of s, I just factorized it out. So you can just factorize it out here. Now, so that we don't have any kind of LCM, you can just multiply both sides with z12. This will become x2 of s, z1, z2 minus z12 square equals to z12 of s. Now you can simply just substitute backward this way. That's what I substituted them into this to make this calculation easier. Before that, you can just write x2 over fs is equals to z12 over z1 z2 minus z12 square. I just simply write what's the way. So this will be your final answer. Thank you for listening. And please like and subscribe.